Hello, I am Nishan. My role deals with the technical aspect of the board. Contrary to what people assume, it's not the larger plastics such as water bottle or plastic covers that create the water pollution and marine life destruction, but in fact it's the microplastic which are formed by the decomposition of the large plastics with the help of the sunlight. So we are trying to eliminate this by making a biomimetic mold which can swim in the ocean, all the while collecting these microplastics and bringing them to shore.
The TI components that are used for the operation of a boat are TMS 5700432 BPZQQ1, the microcontroller, and the driver DRV 888 1ER Both these components are under PCB design. So temporarily we are using another TI component, that is MSP EX P430F5529LP. And these are the 3D printed models that we are going to use. And the most important, we are going to use a 2 gear motors, 1 submersible pump and 1 NEMA 17 stepper motor.
Centrifugation is a physical process wherein which solid particles settle at the end of the circular vortex that is created. The solid particles here, microplastics, although very small in size, propagate in the direction of the vortex. We use this concept to separate microplastics. We have a centrifugation motor, a gear motor that creates vortex. Once the vortex is created, microplastics settle at one end. After this, a shutter closes, trapping the microplastic on one side. The clean water is pumped out and water containing microplastic is let in again. The shutter is opened and the process repeats again, collecting more and more microplastic after each cycle. After creating number of cycles, the bot is taken out of the water, microplastic collected is removed and bot is sent back to the water again.
So yeah, this is the main column and there is a fixed shutter inside this which doesn't allow microplastics to come through it. And if you can see over there, there is a rotor which creates centrifugation, and this is the other side of the cap which holds gear motor to create centrifugation. And this is the cap, and this whole setup of stepper motor plus this mobile shutter goes inside this. The stepper motor fits into this and the shaft comes out through this hole, and this shutter also comes out through this hole, and this whole setup would be plugged in like this, and this would become our one single bot. And this is the motor that we designed ourselves to pump in water which contains microplastics into this bot through this hole. And this is in case if we need an extension for this stepper motor. So as you can see here, we have the stepper motor which is constantly rotating 60 degrees, and it is controlled by this MSP430 launch pad, and the driver we have used here is L298D. So this is the actual process, and at the beginning we can see that there are no microplastics at this end, and as soon as we turn on this motor, we see that the microplastics start collecting at this end due to the process of centrifugation.
Hi, I'm Vivek. I'm going to talk about technical impact of our project. We have done considerable amount of research and we haven't found anything similar to our project. There is this one solution which uses membrane bioreactor technology, which is more expensive and energy intensive than our solution. Our project involves multiple domains, as in it requires mechanical description, which we modeled using AutoCAD. It also requires electronics and electrical domains for navigation and motor controls. It also involves a bit of programming for the controlling of microcontrollers.
Okay, so basically whatever you have planned for this particular project, it's very good and very innovative one also. So basically you can, your main concern was to clean up the microplastics, right? So it's very good. I have heard about the ones who cleaning the larger plastics upon the sea, water, whatever. So this is the first time I'm hearing this. So I think it's a very good one. Carry on.